In this video, we're going to look at the last two of the tests on that summary of convergence and divergence sheet, the ratio test and the root test. So next on the list is the ratio test. The ratio test is, it says all series here. It says all series right there. But really, this one is good when you have combinations of like geometric series, so combinations of numbers to ends, combinations of p-series, ends to numbers, n factorials, so combinations of all of these things. The ratio test is really useful. And what you do is you take a sub n plus 1. So this means that you are going to plug in n plus 1 into your sequence in the sum. So plug in n plus 1 into the sum. Then divide that by when you have just n. Take a limit of that and get a value. If that value, rho, if rho is less than 1, then it converges. And not only does it converge, but it converges absolutely. So if the question was conditional or absolute convergence, you wouldn't have to, it would just converges absolutely. If rho is greater than 1 and infinity is okay, then the series diverges. And if it's equal to 1, then there's no conclusion. So this is the only time that you kind of need to be careful on this one, is if you get your limit equal to 1, you can't use the test. And you would have to use a different one. Okay, some examples. So first example, let's look at the sum from n equals 1 to infinity of negative 1 to the n over n squared divided by 2 to the n. Now notice in this example I have a combination of a power series and a geometric series. This is a great one where ratio test works out really nicely. Now notice that if you look back on your sheet, the ratio test has absolute value. And because it has this limit as n goes to infinity of the absolute value of n plus 1 over a sub n. And so that means that you can just ignore the negative 1 to the n. Don't worry about it. The absolute value would take it out of there. All right, so I ignore the 1 to the n. I'm going to plug in n plus 1 into all the n's here. So I get n plus 1 squared divided by 2 to the n plus 1. And then I'm going to divide that by a sub n, which is the same thing but with just n's. N squared 2 to the n. So this is a limit as n goes to infinity of n plus 1 squared divided by this 2 to the n plus 1. I can rewrite that as 2 times 2 to the n. And then dividing by a fraction, I multiply by the reciprocal. So I flip it and multiply it. And notice that the two n's will cancel. I now have a power of n squared in the numerator, a power of n squared in the denominator. My numerator, the number out in front of n squared is 1. In the denominator, the number out in front of n squared is 2. And now I go back and look at the ratio test. That is our limit. It is less than 1, which tells me that the sum converges. Negative 1 to the n squared over 2 to the n converges. And we used the ratio test. All right. Normally, I don't do this step Normally what I do is I plug in n plus 1 and then I flip and multiply by the reciprocal right away. So I don't normally worry about that division step. It just takes an extra step of writing. All right. Let's see. I think I can do another example on this sheet. So let's look at the sum from n equals 0 to infinity of negative 1 to the n factorial divided by 4 to the n. Oh, one other thing to notice on these is that I have a negative 1 to the n, and that often leads to thinking about the alternating series test, but showing that these a sub n's, showing that that limit goes to 0 is a little bit difficult, and then also showing that the next term is less is also difficult. And in fact, on this second one, the limit doesn't even go to 0. So that doesn't even, the alternating series wouldn't even work on that one. Okay, so I'm going to take a limit. As n approaches infinity, I ignore the negative 1 to the n because of absolute value. I plug in n plus 1, so n plus 1 factorial divided by 4 to the n plus 1. And then I am going to multiply by the reciprocal when I plug in n. So I flip and then, well, I plug in n, flip it, and multiply it. So I'm doing that division kind of all in one. All right, so this is the limit as n goes to infinity of n plus 1 is n plus 1 times n minus 1 all the way until we hit 3 times 2 times 1. And I still have 4 to the n in there. All divided by the 4 to the n plus 1. I can rewrite that as 4 times 4 to the n. And then n factorial is n times n minus 1 all the way until I hit 3 times 2 times 1. So there's a lot of stuff in here that cancels. The 4 to the n's cancel. The whole n through 3 times 2 times 1 cancels. And now if I plug in infinity in this limit, I get infinity. And infinity is bigger than 1, so this diverges. The sum from n equals 0 to infinity of negative 1 to the n factorial divided by 4 to the n diverges. Diverges by the ratio test. All right, next test. All right, the last test on that sheet, the root test. So this one, I know it says all series right there, but really I only use it if you have an nth root of something. So this nth root right here is the only time you will ever use this test. Otherwise, taking a limit with an nth root gives you something raised to an infinity, which is very, well, it's hard to deal with in limits. All right, so let's see, I think I can do an example here. Let's look at the sum from n equals 1 to infinity of n raised to the n all over 3 to the 1 plus 2 to the n. All right. Now, I want to use this because it's raised to a root n. So really what that means is something raised to the 1 over n. And what this test says is that I'm going to take a limit as n goes to infinity of the absolute value. Now, there's no negative 1 to the n in here, so I don't even have to worry about it anyways. Of our whole a sub n, and then I'm going to raise that to the 1 over n. All right, so this would give me a limit as n goes to infinity of, in the numerator I get n, because I've got n and then raised to a 1 over n, so that just gives me n to a first power. And then in the denominator, if I multiply through the 1 over n into that exponent, you may have to review rules of exponents to see that what I'm doing here really does work, it's legal. I'm multiplying through the 1 over n into that exponent. And when I take the limit, as this goes to infinity, 1 over n goes to 0. And so essentially in the denominator, I get 3 squared. So I get just 9 in the denominator, and in the numerator, I get infinity. So in this limit, we get infinity. Infinity is bigger than 1, and if it's bigger than 1, then the sum, the original sum of n to the n, all over 3 to the 1 plus 2n diverges. Diverges by the root test. Let's look at one more example, but notice that the reason I used the test here was these raised to the n's powers. So another example using root test, we could look at the sum from n equals 0 to infinity of 5n minus 3n cubed all over 7n cubed plus 2 raised to the nth power. Notice the raised to the nth power. It doesn't come up very often, and when it does, root test is definitely the one to use. So we're going to take a limit as n approaches infinity of the absolute value of 5n minus 3n cubed all over 7n cubed plus 2. And it's the absolute value of that to the n. And we're taking, let's see, I have to look back on that sheet right now to see it's the nth root after that absolute value. So the n and the 1 over the n, when you multiply them, give you 1. So we're taking a limit now as n approaches infinity of the absolute value of 5n minus 3n cubed all over 7n cubed plus 2. The powers are the same. And because the powers are the same, we're going to pick the numbers that are out in front. The numerator, the number out in front is -3, and the denominator, the number out in front is 7, and if you take the absolute value, we get 3/7. Now I'm looking back at the sheet. 3/7 is less than 1, and so we get convergence here. From n equals 0 to infinity of 5n minus 3n cubed all over 7n cubed plus 2 to the n is going to converge. And actually, not only does it converge, but it converges absolutely, if that was the question. It converges absolutely, and we used the root test. All right, we have now gone over all of the tests that are needed. And so now, whenever you see a series, you are going to have to choose which of these tests to put to use.